Today we are going to start the current divider and the voltage divider law. Now first we are going to start the voltage divider law. Voltage divider law. Now you check here. I just put three resistance that is the ground, and this one is the plus VCC. You can consider this circuit R1, R2 and R3. So obviously current is going from the top to the down I. Now the same circuit, if I draw with the help of a battery, then it looks like this. This is the plus, this is the minus. R1, R2 and R3, and the current is going from this side I. Now here what happened, first we have to calculate the current passing through this circuit, plus to minus. How much the current? Suppose this one is the V voltage, the same like the VCC, V voltage. So V equal to I into R. This is the Ohm formula. So here how much I? R resistance. Resistance you will find that here there is a three resistance, R1, R2 and R3. So here the R, equivalent resistance R, that is equal to I into, within bracket, R1 plus R2 plus R3. So if I calculate the current I equal to V divided by R1 plus R2 plus R3. Now as the law is the voltage divider law, you have to calculate the voltage across each resistance. This is the V1, next one is the consider V2, and the third one consider V3. So just consider the V2. How much is the voltage for the V2? V2, as per the Ohm's law, V2 equal to I into R. Here how much is the I? I is the same current flowing through the circuit because the series circuit. So I is same for the R1, for the R2 and for the R3. But for the R is different. So I into R is what? We are going to consider the voltage across the R2 resistance. So R is R2. So now if I insert the value of I, then what we will get? We will get I equal to V divided by R1 plus R2 plus R3 into R2. So if we just minimize the formula, then we will get, or rearrange the formula, then we will get the total voltage across the circuit into R divided by R1 plus R2 plus R3. So here R2. Now if you check, this is only for the three resistance. If it is a more than three resistance, and based on this formula, this is a very easy formula. Based on this formula we can find it out any voltage. So V1 it should be capital V into which resistance? V1. So it will be R1, and the down resistance is R1 plus R2 plus R3. If 4 resistance or 5 resistance, if n numbers of resistance, then for any resistance, suppose the kth resistance voltage we want, then V into Rk divided by summation of R, means all the resistance summation, I equal to 1 to n. So this is the exact formula for any circuit or any voltage divider circuit. Now you check, I just going to solve one problem here, some small spaces here, so we can solve here itself. Now we can consider 10 volt supply. Here the resistance 3 ohm, 2 ohm, 3 ohm and 2 ohm. Complete the circuit. Now you check the total resistance R, that is equal to 3 plus 2 5 plus 3 8 plus 2 10. So the 10 ohm resistance. We want to know the voltage across the 3 ohm resistance. How to get? Now the formula, we will apply the formula. V3 means the you can consider V1, V2, V3 and V4. So the total voltage, you have to apply the total voltage into total resistance divided by the resistance across R3, that means the V3, this resistance. So here you will find the V equal to the 10 volt into R3 is how much? 3 ohm. And how much is the R total? 10 ohm. So cut this two, you will get 3 volt. So okay guys, now come for the current divider law. In this current divider law, I just already make the circuits. Here you can find it out. So, one current is entering here, and this current is divided into two parts, I1 and I2 in the two resistance in parallel, R1 and R2. Okay, then the same current is going out because the current there is no chance to go current anywhere else. So I1 is entering, that is divided I1 and I2. Again, these two currents joins and make the main current. So I equal to I1 plus I2. Now, if we consider in the A point is here and B point is here, then in A and B point, the equivalent resistance we can consider 1 by R1 as 1 by R2, that is equal to R equivalent equal R1 R2, R1 plus R2. If you don't know how to make the equivalent resistance, you can go through the previous video where I describe how to make the series connection and how to make the parallel connection. Now, if we consider these 2 points and we can consider the main current I, then the voltage across A and B points, we have a V equal to I into R. Now check this R. R is nothing but the equivalent resistance I into R1, R2, R1 plus R2. The same thing we insert here. Now you check for the A and B point, this side voltage and that side voltage also same. You can consider, just I am going through it with a different color. This side voltage and that side voltage, both are same. So if you go for the upper side, that will be V same equal to I1 into R1 equal to, if you go for the downside, I2 into R2. That is also equal to the same voltage. Okay. So now what we will do, now we have to find it out the current I. So how we can get it? I put it here, I cross this R1, here R1 cross and here R1 cross. So automatically we will get I1 equal to I into R2 divided by R1 plus R2. Just R2, R1 plus R2. Now for the I2 just I am going to show you here how we make it. I2 equal to cross R2, this R2, this R2. Finish. So I2 equal to, you will get I into R1 divided by R1 plus R2. Here there is a tricks. There's a very good tricks for remembering this formula. Just when if anyone gives you the problem, no need to go for all these equations. So just you have to follow the formula. Here I1, if you go for the I1, obviously there should be the main current. Multiply with here I1, so obviously here should be the opposite resistance, not like the voltage divider, opposite resistance. But here in the down, all resistance should be added. There is also I2. So equal to I into R1. Here 2, so here is 1 divided by R1 plus R2. Now go for the on formula or one problem. A simple problem is here. 5 ampere current is entering here. Now divided into two parts, I1 and you can consider here I2. Now resistance is 1 and 2. The current is again comes here. This is the 5 ampere. Now here you check as per the formula I1. We are going to find it out. So 5 ampere should be here into as I1, so it should be the opposite resistance 2, so you put 2 and down we have to put the 2 resistance addition 1 plus 2, so 1 plus 2 equal to 3 and 2 here up, 5 into 2 10, here 3, so 3.33 ampere. How easy this is? It's very easy to solve. So now If you find this type of problems in your big circuits, then easily you can solve with a 1 and 2 the steps with the help of this current divider law. So gradually in this channel, we are going to solve big problems and we are going to enter the critical thinkings in electrical engineering. So if you are liking this channel, please subscribe and please forward these channels to your friends, those who are studying the engineering and those who are willing to study engineering and blah blah justice. It will be helpful for the students and it will be helpful for the beginners. Thank you for watching.